Uh, Today's program will discuss about demonstrating race condition among parent and child processes. So we know that when a parent process forks a child process, many resources that were being used by the parent will now be shared by the child process. So it is but natural that because both of them are sharing a lot of resources, they would compete to use those resources, which will result in a situation called race condition. So race condition is a condition situation in the system that will actually make the processes compete for several resources, and between parent and child, because there is a lot of sharing of resources, there will definitely be a competition to use those resources. So to demonstrate race condition among parent and child processes, we have a sample program here. In this program, I call a function called char at a time in both the child and the parent processes after forking uh, the child process. So if you look at the definition of char at a time function, initially I am making the standard output unbuffered. So by setting the standard output unbuffered, every time I call putc here to output a character, it will internally invoke write system call. So there won't be any buffering of characters being done here. Every putc will actually internally trigger a write system call that will write the character immediately to the standard out. Okay. So by making this unbuffered, I make this standard output the shared resource between the parent and the child. So when the parent as well as the child calls this char at a time function with different characters here, if you see in the function char at a time called by the child, I have output a stream of letters C, okay, and in parent I have the letter P, the character P output several times. So I have made the string long enough so that I can demonstrate race condition. Okay, so this is the program. Now when we go back and compile this, so there is no compilation error seen there. So I just execute it. Now when I execute it, you can see that uh, the parent got a chance to execute first, so it output all the characters here. Then the child process got a chance and it called the char at a time and it output. So here uh, by coincidence I don't see any intermixing of output. If they both compete for the same shared resource, the standard out, there should actually be an intermixing of output when you actually demonstrate this. So what I would just do is I would increase the length of the input string. Okay, both the cases, let me just add a couple more C's and few more P's here, and then execute it again. So now you see that there is intermixing of letters P and C here. That shows that both the child and the parent, when they were competing for the same device, the standard output, as they output, the output from both the processes is getting intermixed and being displayed as a cluttered output on the standard output. So this is how you can demonstrate race condition amongst parent and child processes. Okay. So next we will look at how signals are handled, how to use signals in Unix environment. So here I have one program here. This program is using sigaction system call. I will have to register a signal handler for sigint signal. Sigint signal is actually generated when you press Control C key combination. Okay, so usually in Unix and environment we press Control C to interrupt the execution of a process and terminate it. Okay, by the default action of sigint is to terminate the process. Now here I will have to define a user defined signal handler that will actually get executed when you press Ctrl C. Okay, but there's a small variation in the program. So after you press Ctrl C the first time, it should be the signal should be accepted by the process, and it should execute the user defined signal handler, and then it should reset the action of the SIGINT signal to its default. Okay, so now here, because we are supposed to use sigaction system call, that's a better way of handling system signals in Unix environment. Because it's a system call, it's efficient to be used. Okay, so I will have to define a variable of predefined structure called struct sigaction that will have a couple of fields. So if you look at the different fields of sigaction structure, so there is SA underscore flags field, which I am setting it to 0 here. Then I am making the signal set to be empty, and then passing it as the one of the fields SA underscore mask to sigaction structure. And then now after emptying all the signals in the signal set, I only add, using sig add set, I only add sig int signal to my signal set, so that whenever sig int is generated, that particular signal is what is uh, notified to our process. Okay, so other signals are actually masked. So by doing these two actions, sigempty set, calling sigempty set function, you are initializing the signal set to be masked to empty, and then sig add set function will add only sig int signal to my set of signals to be notified to the process. All other signals will be blocked even if they are generated. Then I set the SA underscore handler field of sig structure to the address of a function called handler, which is user defined, that I have defined it here. So this handler basically, uh, to confirm that this handler was executed, I have a printf statement here that says Control C was actually received, the interrupt was received, and then after this receipt of the signal, and signal is handled with the handler user defined handler, I have to reset the handler to the default action, right? So that is what is being done in the function next. So SA underscore handler is set to sig underscore default, and you call sigaction again. So when you call sigaction the second time, you are actually registering the handler. Whenever interrupt is received next, Control C is pressed the second time, the default action for SIGINT should be performed, which is to terminate the program. Okay, so I call sigaction first here, and I call sigaction the second time inside the handler function. Now I put the process into a infinite while loop and terminate it using the second time Control C option. Okay, so let's I have inside the infinite while loop, I have a printf statement, and then this printf executes once in every second, because I'm putting the process to sleep. Every second the process wakes up, prints, and gets back to sleep. So it's printing progress is happiness every second. Now when I press Ctrl C for the first time, okay, it printed the message interrupt received, which was actually the printf that you have inside the handler, right? Now when you press Ctrl C for the second time, it should apply the default action for the SIGINT signal. The default action is terminate. So when I press Ctrl C for the second time, it is terminating my process. This is how I could use sigaction system call to actually register signal handlers for specific signals, and then whenever generated, the signals are generated, you catch them and handle them the way it's specified. Okay, there's one more program that you will have to use signal function, C library function, and uh, handle signals. Okay, so in this I am actually uh, using the signal function that's defined in the signal.h header file. Okay, and then I am trying to register the handler. Here again I have a similar program. Okay, but there's a small variation. I have to handle two different scenarios. The first case is I have to call the signal handler, user defined handler, when I receive SIGINT signal, when the SIGINT signal is received by the process, and then the second control C should actually reset to the default action of the SIGINT. Okay. In the second case, I have to ignore the SIGINT signal for the first time and then reset the default action to the second time when control C is pressed. Okay. So if you look at the program, I have inside main, I ask for the choice from the user whether I want case 1 to be executed, in which case I will call the user defined handler and then reset to default, or it's case 2 wherein I ignore the signal for the first time and then reset it to default the second time. Okay, so that's what is being done in main. And inside the while loop I just want to make sure that in the second case the ignorance of the signal, the sig underscore ignore, is actually executed and the user should actually visualize this. For that reason I just make sure that this particular while loop iterates for a minimum of 5 times between the first control C and the second control C, so that you can easily visualize that you pressed control C twice. The first control C was ignored, the second control C actually took the default action. Okay. Again in the callback I have a similar printf statement and then I call signal again to reset the SIGINT action to default. Okay, sig default. Sig underscore DFL is to set it to sig default action, and then sig underscore IGN is to ignore the signal. This is the case 2 first time. Case 1 first time is to call callback. Okay, so if you now look at how this program works, let me say I want first case. Okay, so it's asking me to press Control C. When I press Control C for the first time, the message interrupt received is actually displayed. This is from our handler function, the callback function that I registered as the user defined signal handler. Now when I press Control C for the second time, the default action is to terminate the process. Okay. Now let's execute the same process with choice 2. Okay, wherein the first control C key combination that generates the SIGINT for the first time, that signal should be ignored. Okay, and the second control C should actually uh, generate or take it to the default action. So here choice is 2 and I press control C. Okay, so the first control C is actually ignored, right? The second control C will terminate the process, right? So this is how signal function, C library function, is used to handle signals in Unix